All right, lesson 3.5. So in this lesson, we are proving lines are parallel. So in the previous lesson, we learned about all the different angle pairs that are formed when parallel lines are cut by a transversal. So our corresponding, alternate interior, alternate exterior, and consecutive interior. So what if we have the converse of that? Could we use the converse to say, oh, the corresponding angles are congruent, therefore the lines must be parallel. So the theorems that we're getting today are all converses of the theorems in the last class. So if you look at the first one, the converse of the corresponding angles postulate. So this says, if two lines are cut by a transversal so that a pair of corresponding angles is congruent, then the two lines are parallel. So if I look in the figure over here, if I look in this figure and I see, oh, angle 2 and angle 6 are congruent, those are corresponding angles. So if the corresponding angles are congruent, then my lines have to be parallel, okay? So it's kind of like saying if angle 2 is congruent to angle 6, then line J is parallel to line K. All right, and so that's how you would use it in a proof. If you're trying to prove lines are parallel in a proof, you would use the converse, okay? All right, look at the next one. Alternate exterior angles converse. So again, it says if two lines are cut by a transversal so that the alternate exterior angles are congruent, then the two lines are parallel. So in the picture over here, if you look at angle 1 and angle 8, those are alternate exterior angles and they are congruent. So then we can say if angle 1 is congruent to angle 8, then line J is parallel to line K by the alternate exterior angles converse. All right, next one, consecutive interior. Remember, this is the odd one out, consecutive interior. So remember, those are the ones that are on the same side of the transversal and in between the lines. All right, so if two lines are cut by a transversal so that a pair of consecutive interior angles is supplementary, remember, these are the only ones not congruent, then the two lines are parallel. Okay, so over here in the picture, if I know that the measure of angle 3 plus the measure of angle 5 equals 180, then line J is parallel to line K. All right, last one of these. Alternate interior angles converse. So if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Okay, so over here in our picture, angle 4 and angle 5 are alternate interior angles. They are also congruent. So if angle 4 is congruent to angle 5 or vice versa, then line J and K are parallel, okay? So anytime you're proving lines parallel, you're going to use the converse of all of these angle theorems, okay? All right, one more converse, the perpendicular transversal converse. So remember the perpendicular transversal theorem says if you have parallel lines, and the transversal is perpendicular to one of the lines, then it's also perpendicular to the other one. So if we flip that, remember converse is the swap. So if we just flip that around, it says if two lines are perpendicular to the same line, then the two lines are parallel. So you can see in the picture that P and Q are both perpendicular to the transversal R. So therefore, P and Q are parallel. All right, let's look at some examples really quickly using these converses. So we're proving lines parallel. Can you prove them parallel? Explain your answer. So if you look at A, look at the two angles that are marked congruent, okay? Those would be alternate exterior. So if they're congruent, are lines A and B parallel? Yes. And the reason is the alternate exterior angles converse. Okay? All right, B. We've got, again, two congruent angles. What kind of angles are those? Same side of the transversal, same side of the parallel line, so they are corresponding angles. If they are congruent, which they are, then the lines are parallel. So yes, because of the converse of the corresponding angles postulate. That one's a postulate, not a theorem, okay? All right. Next one, angle 1 and angle 2. Look where those are located. It says that they are supplementary. They add up to 180. These are alternate interior angles. So in order for the lines to be parallel, alternate interior angles have to be congruent, not supplementary. Okay? So no. Angle 1 and angle 2 need to be congruent for the lines to be parallel. All right, let's look at number 2 down here. This time we're doing some algebra, so find the value of x that makes line M parallel to line N. So we're going to look at these two angles. What kind of angles are these? Same side of the transversal, both sitting on top of the line, so they're corresponding. So if these are equal, the lines will be parallel. So your equation is 3x plus 5 equals 65. And then we just solve for x. So 3x equals 60 and x equals 20. All right, number 3. Again, find the value of x that makes M parallel to N. So look at the two given angles. We know this is x, this is 180 minus x. What kind of angles are we looking at? They're on opposite sides of the transversal, and they're both on the outside of the parallel lines. So these are alternate exterior. And in order for the lines to be parallel, they should be congruent or equal. So 180 minus x equals x. This one looks kind of funny. I'm going to add the x over, so we get 180 equals 2x. Divide by 2, and x equals 90. So if x is 90, those will be congruent and the lines will be parallel. All right, I think we have just a couple more on the next page. I'm trying to go fairly quickly so that this is not a super long video, but remember, you can go back and rewind and listen to something again if you miss something. Okay, so take a look at this one. Again, find the value of x that makes M parallel to N. So look at our two given angles. Same side of the transversal, and they're both in between the lines. So they are consecutive interior. And it says if consecutive interior angles are supplementary, then the lines will be parallel. So that means they have to add to 180. So that gives us 3x equals 180 and x equals 60. Not too bad. All right, one more. Is there enough information in the diagram to conclude that M is parallel to N? Okay, well, if we're looking at the picture, we have the 75-degree angle here and the 105. Is there any special relationship between these two? No. But it's saying, is there enough information? I know that this angle right here makes a linear pair with 105. So those are supplementary. So I could figure out that this angle is 75, right? 180 minus 105. And if that angle's 75, what kind of angles are the two 75s? They're corresponding. And if corresponding angles are congruent, then the lines would be parallel, right? So yes, there is enough information. We know that the corresponding angles are congruent. Okay? Awesome. All right, let's do a little proof, and then I'm going to make a separate video with a couple of other proofs that you can watch. Okay? So this first one, we are given this figure over here, and it tells us in the given statement that R is parallel to S. So I'm going to mark that with the little arrows so I remember. And it also tells me that angle 1 and angle 3 are congruent. I'm trying to prove that line P and line Q are parallel. Okay, so if you look at that, what do I need to know so that P and Q would be parallel? If I knew that angle 2 and angle 3 were congruent, the alternate interior angles, wouldn't P and Q be parallel? So that's what I'm going for, okay? So I need to think of a way to include angle 2. All right, so you're given all the statements this time. The first reason is given. The second reason is given. So they just listed both givens right off the bat. Okay, the next step, angle 1 is congruent to angle 2. So they're saying angle 1 and angle 2 are congruent. Here are your parallel lines. If Q is your transversal, do you see that angle 1 and angle 2 are corresponding angles? So we're using the corresponding angles postulate. We already know the two lines are parallel. So we're using the regular postulate. If they're parallel, then the angles are congruent. All right, now let me get my trusty highlighter. Okay, does everybody see that angle 3 is congruent to angle 1 and angle 2 is congruent to angle 1? So angle 3 and angle 2 are congruent. That's our favorite thing, transitive POC, because we have the congruent symbols. All right, so we said at the beginning, if we could get angle 2 and angle 3 to be congruent, then line P and line Q would be parallel because they're alternate interior angles. So since we're proving the lines parallel, I'm using the converse. So I'm using the alternate interior angle converse. Okay, so there's a proof example, and then I'm going to do a couple of proofs from your proof packet in a separate video.